Hello friends, welcome to our channel Google Galaxy. Today we are going to talk about the colloidal solutions. We know that the solute is one which is limited in quantity, while the solvent which is present in excess. When we dissolve sugar in water, sugar which is solute, solvent that is water, when we mix sugar and water, the combination of both becomes the solution. Similarly, here NaCl is acting as solute while water and benzene in excess, so we called as solvent. When we mix solute and solvent, it becomes the solution. The Thomas Graham scientist noticed that the behavior of solute in different types of solvent, the different behavior of solute in different types of solvent. But he found that when we mix NaCl in water, the size of particle is very much small, while when we mix the NaCl in benzene type solution, the size of particle is much larger. The size of NaCl particle is much larger than that of solution in water. So, depending upon the size of particle, with the variation in the size of particle, there are actually three types of solution based on the size of particle. These are true solution, suspension, and colloidal. So, depending upon the size of particle, the overall classification of solution is divided into three. One is true solution, another one we are having the suspension, and the third one we are having the colloidal solutions. True solutions are those where size of particle is very much smaller. We can say the size of particle is less than the size of particle is normally less than 10 raised to power minus 9 meter. You have to learn this value as it is. The best example for true solution is NaCl in water. This is the example of true solution. Remember one thing, we cannot separate the NaCl from water with the help of filter paper. This is the characteristics. This one is the identity, that how we, if the teacher placed two beakers in front of us, beaker A, beaker B, both are having solute and solvent, both are having the solution. If teacher asks you which one is true solution, which one is colloidal solution, so how you can identify? You can identify from the following written characteristics. But you will see, you will have to pass this solution from the filter paper and the animal membrane. If it is passed from the both filter paper as well as animal membrane, so we named as true solution. If it is passed, if the solution B, similarly if the solution B pass from the filter paper but not pass from the animal membrane, so we say it is not a true, it is a colloidal solution. Similarly, if it is not passed from the filter paper as well as animal membrane, so we named as suspension. So why the particles do not pass from the filter paper and the animal membrane? Because the size of particle varies. The size of particle in true solution is very much smaller, that the filter paper cannot restrict them. So the size of particle is very much smaller, that we cannot see with the naked eye, not with the naked eye. Similarly, the third point is that it can pass through, as I told earlier, it can pass through filter paper as well as animal membrane. This is the advanced membrane. This is the another way of finding the size of particle. This is another way of identifying the that whether it is a part of true suspension or colloidal. These are the few characteristics through which you can identify the solution easily. Similarly, we are having the colloidal. Okay, let's talk about the suspension first. The suspension, here the size of particle is very much larger that we can easily see with the naked eye. That we can see with the naked eye. Another point of solution is suspension is that the size of particle. That means if I just mix sand in a water, the sand in a water we can easily with the naked eye. Why is it so? Because the size of particle is about 10 raised to power minus 6 meter, more than 10 raised to power minus 6 meter. Now you can imagine how much larger the particle is. The size of particle is that it cannot pass through both filter paper as well as animal membrane. It means that both of the filter paper does not allow it, do not allow the particles to pass through. So what about the colloidal solution? Colloidal solutions are those, what are the example for colloidal solution? That if I just mix soap in a water, the particles, if I just mix soap in a water, the overall solution behave as a colloidal. So what does colloidal means? That the size of particle is an intermediate of true. The size of particle lies between the size of true solution and the suspension. Also we can take an example of milk. The size of particle is lies between 10 raised to power minus 9 in between 10 raised to power minus 6 meter. Yes, it cannot be seen with the naked eye. Next we are having that it cannot pass through filter paper. It can pass through filter paper but not through animal membrane. So not possible to pass through. So this one is the best example. The example for colloidal is soap in water. You have to just remember two examples, need not to worry about more than two examples. The teacher will never mark you wrong. The teacher will never ask more than two examples in the examination point of view. If I just say in the, okay, we are having the true solution to sugar in water, sand in water. What about the Tyndall effect? Tyndall effect is the scattering of light when it is passed through solution. If I just pass a ray of light, if I just pass the number of rays, if I just pass the torch light from this solution, what we will see on the other end, it will start scattering. So this type of effect we called as Tyndall effect. The scattering, the behavior of solution to scatter the light we called as this effect as Tyndall effect. So colloidal are always having the Tyndall effect. So we say that the suspension does not the suspension shows colloidal yes, colloidal is definitely show the behavior of Tyndall effect. The true solutions does not show the effect of, does not show Tyndall effect. So appearance wise it is opaque. This one is transparent, and this one is also transparent. Similarly, what about the Brownian motion? Brownian motion is the movement of solute particles in a solution. If I just drop pollen grain in the solution of colloidal, what we will see? We will see zigzag path. Zigzag path, that is random path in the movement of pollen grain. So this type of movement we called as Brownian motion. So in case of uh, suspension, it may show definitely in the colloidal solution it shows the Brownian motion. It may or may not, it may not or may not show the Brownian motion. This is all about the true solution, suspension and colloidal.